So IP version 4 is a 32-bit logical address and it's a unique address, okay, that is used to identify the devices in your network. And one more thing, the IP address is developed by ITF. ITF is the organization Internet Engineering Task Force, and IP address distributed by the Internet Assigned Number Assigned. It is assigned, right? So how this INA assigned this type of IP address for all the world, for every device? So for that we have something like, suppose we have this IP address. So INA divide this IP address, divide this. Firstly, we will talk about this IP version 4. So INA divide this IP version 4 into five classes, right? Into five classes. So firstly, if we talk about the five classes, how it will define. So here you can see IP version 4 address divided into four parts. If you will see any IP address, suppose I just write this 192.168.10.5. This is the IP version 4 address. So here you can see we have four fields, right? We have four fields and every field separated by the dot, right? Each each uh, each field is separated by the dot, and the size of single field is 8 bit. 8 bit. So we can say this is the octet because of 8 bit. Right? So this is the octet. So we have four octet available in IP version 4 address, and every octet is separated by the dot and represent in decimal number. Decimal number means what? 0 to 9. Here you will see only 0 to 9 number. And the next thing is, as we discussed, here we have 8 bit. 8 bit means what? As earlier we discussed, bit means what? Bit means the digit of binary. It can be 0 and it can be 1 also. So in octet range, we have this range. It can be the range. Means the minimum range can be 008 times for 8 bit, and the maximum range can be 118 times. Right? So 008 time and 118 time. If you will convert this binary into decimal number, then you will get this. Means for this 00, it will be the 0, and for this 118 time, it is just 255. Right? So that means if you are using IP version 4 address, then you can give only this range from 0 to 255. Only this can be the IP address. This can be the range of your IP. 0 to 255. Always we have to remember. And one more question. Is there anyone who don't know how to convert the binary into decimal and decimal into binary? Just let me know. If you don't have any knowledge about this, then I can show you how we can convert. Otherwise, we will go to next topic. You can see here the range can be from 0 to 255. So that here you can see I now divided this IP version 4 address into five classes. So here is the class. Okay, so now see I now divided this IP version 4 address into five classes. The class A range is, in some books, the range is from 1 to 126, and there in notes section that is mentioned 127 is reserved for the loopback and 0 reserved for the default loop IP. I will also tell you about that in brief method. But for now, in some books that is 1 to 127, and in some books that is 0 to 127, and in some books that is also available. So 127 is reserved for the loopback. That's okay. So now can anyone tell me what's the mean of loopback? Then we will discuss about this zero. Where this loopback works. Okay, so loopback means what? Loopback means it's a self-host address. Self-host address means it's a address of your NIC. Means by default, it's the address of your NIC. If you want to check your NIC, then you can use this address. You have to just ping with this IP. If you will ping a IP that is started with 127. After that, any digit can be right 5.4.6, any digit. If you will ping with that IP, or with this range. After that, if you will get reply. So that means your NIC is working. Otherwise, if you will get any error with this with this range of IP address, then that means your NIC is not working. Problem is with your NIC. So you have to need to check or change your NIC in that case. So that is the mean of loopback. Let me show you how we can check this. Here you can see if I will ping with some IP like google.com, right? So now I can get that a reply, right? That means I am connected with the internet. I am connected with the google.com. Okay. If I will ping with my gateway or my router IP, so what is my router IP? Do you know? Is there gateway? This is gateway. 192.168.78.1. Okay. Just a minute. Now see, this is my gateway. If I will try to ping with this IP, so I can also ping 192.168 or 78. Okay. 192. 168.78.1. So now if I will hit enter, so I am able to ping with that IP also, right? Because my network is working, my NIC is also working. And now if I will check for another IP, suppose I think maybe there 25 is there. It's not there. IP. Yeah, destination host computer. It's not there. So now what I will do, I will do one more thing. I will, mhm, let's connect it. Now if I will open ncpa.cpa, run, in run I will type ncpa.cpl and if I just disable this NIC, I will disable all the NIC. Right? I just disable. Now there is not working any NIC with any network. Now if I will try to ping CMD, ping space google.com. So you can see here, I can't ping with that. Now if I will try to ping with my gateway 192.168.78.1, general failure. I'm not able to ping with any IP address. But in this case, I can also ping with myself, with my same ID. That is 127.0.0.1. And now you can see it's getting reply. So this is how we can check RNI, right? If any problem will occur with your network, with your cable, or with anything, or after that, if you will check with this IP, by this IP you can check your NIC. Is your NIC is working or not? So my NIC is working. That's okay. Now I have to need to check other things like the cable and the network and the network device, switch, router, everything I have to check. But don't need to check on my NIC now because my NIC is working. So this is how we can use loopback address to check the NIC. Everything is disabled in this machine, but loopback is working. Because always loopback works if you disable anything, if you do anything with your system, loopback will work. Right, so this is the mean of loopback. Now just let me know, is that clear for everyone? Loopback, how we can check with loopback. So this is the use of this 127. Then we have 0. So 0 is reserved for default route. Default route. Default route means what? Suppose as we discussed for the router, If you want to connect two different network and more than two different networks, then we have to need a router. So we will connect this type of router topology, net router, and in every router we have switches and PC also available. And this is the network. Now, suppose the best thing is with the router. If you want to add any network, so firstly you have to know about that network. Means suppose this is my first router. I want to connect this router with the third one. So firstly I have to add that network in routing table. And this is the thing. So for that, suppose I don't know about that destination net. I don't have any idea about that network or the IP. So how we can add? So for that we have to need that IP, but I don't know about that IP. So I can't connect with this router with that network. That's so this is a fact with the router. So now what we can do, if you have not any idea about the destination network, so you can create a default route. So default route means what? You can create an entry with 0.0.0.0. You can create this route, and then the subnet mask will be also 0.0.0.0 space, and then you have to just give the best route. Best route means next route. The interface which is directly connected with you. For first router, my interface is this was. So this IP I am knowing because I am directly connected with this. So I can ask. So I will ask that network and I will just explain this network 10.0.0.1 or any IP. After that, I can connect with this network also. Because when you enter this network 00, after that it will send this packet in default route in this side. Any router which is available in this default route in this line, so that will be able to receive the packet from the first one. So this 0 is used for the default route. That when we will do the routing maybe tomorrow, so then we will see how we can add this 00 in router. I will show you that. But for now, this 0 is used for default route. Now, if you will talk about these classes, so starting three classes like A, B, and C, they are reserved for the computer network. These classes are reserved. Means only IP started from 0 to 223. You can use your own system in your laptop. If you will try to assign this 2 to 4, you can't assign that IP on your machine. Right? Only this is the range. So let's see how we can check this. So if I will try to assign the IP address, Internet Protocol version 4, use the following IP address, and here I will type. Suppose I will type 0. As we discussed, 0 is reserved. So we can't use that 0 in any machine. So 0 dot mhm. When I type 0, there is a error. 0 is not a valid end. Please specify a value between 1 and 223. That here you can see this error. You can assign the value between 1 and 223 only. If you will try to assign 127 also, 127, it's showing you IP address starting with 127 are not valid because they are reserved for loopback address. Please specify some other value between 1 and 223. So now if I will try to assign 224, 2, 2 and 4, it's showing 224 is not a valid entry. So that means we can only assign the IP address between 1 and 223. And that means class A, B and C. And in class A we have two IP reserved 0 and 127. So that we can't assign that IP also. Right, so here you can see. And after that this class D. So can anyone tell me where this class D used? So first thing is for this type of IP for class D IP, We have some other type of devices, some other multicast devices. I think in your country also, I think sometime at like on some occasion, your means the prime minister or the president or sometime your chief minister send some message to all the public like Happy New Year or like Happy Diwali, Happy Eid, this type of message they send. So how they send this type of messages to all the public by same time. So they use this type of devices in which they can use this multicasting, that multicasting. But where we can see this type of IP, so we can see in some routing protocol where you do routing on router. So suppose I'm just doing routing in between two routers. We have two routers. So in that case, if I will configure the dynamic routing on this first router and second router, dynamic routing. So dynamic means automatically it will configure the best. So that means I will configure some protocol because where the word dynamic comes, that means we have some protocols also. Otherwise, how it will configure the best path? So we have some protocol. We have the RIP protocol. We have OSPF. We have EIGRP. That is the name of protocols, routing protocols. So we will configure this type of protocol on the router. Then automatically this router will configure the best path. So how it will configure actually? If you will just configure this RIP, OSPF, EIGRP. In every case, when you configure this type of routing protocol on the router, then router will exchange the routing table with all the router which is available in same network. So that means suppose if we have three routers, so in that case, this first router will send the routing table to second one. Then the second router have the two routing tables. Means first router table routing table and the second router routing table. So it will just configure that and create a single table, and then it will send this table to third one. After that, if this third one has three tables, so it will configure and it will just club that and create a single routing table. Then it will send this table to first one. After that, they will just create a single routing table and everyone has all the network information. So when it will just multicast this routing table because in this case, first router sent this table only first and first sent it only to the third and third sent only to the fourth. Means one by one, it's just doing multicasting, one to many. It's just doing multicasting. So that time router use this type of IP. Let's say we take the example of RIP. So RIP uses to exchange the routing table 224.0.0.5. This IP it uses in backend. We can't interact with this IP, we can't change this IP, we can't configure this IP, but in backend this IP works for this purpose, right? And if you are using OSPF, so we have two IP, 224.0.0.8 and 9. Mhm. This two IP works, 8 and 9. So there you can see this type of multicasting IP in network case, right? So now tell me, is that clear now? Multicasting, where we can see this multicasting in our case.
Yes, sir.
Now next is class E. So the question is where this class E used. So this class of IP address means class E IP address reserved for research and development purpose. So research and development means INA reserve this type of IP when any technology be invented will be invent that time this type of IP address will be reserved for that type of devices. Like suppose 5G is invented, right? If 6G will invent, so that time uh, scientists has to use any IP to create that type of devices, the 6G device or some other applications. So that time they will use this type of IP with this class E IP. The range is 240 to 255. That means this type of IP is not available over the internet and in any computer network also. Right? So there, this type of IP address is used. So now you can see here, so we have this classes, class A, B, C, D, E. Class ABC is reserved for computer network. Class D reserved for multicasting. Class E reserved for research. And here we have this 0 and 127 is reserved for the default routing and for loopback. We have one more thing, 0 and 255. Right? 0 and 255 means what? As we discussed the classes of IP address. So there is one rule. One rule means what? Always first octet, first octet of IP denotes class of IP. Means by first octet you can identify the class of your IP. Suppose I am just writing one IP. There is 192.168.10.5. So now can anyone tell me the class of this IP?
Class C.
Class C, right? Class C. Because in first octet we have this 192. And if you will see in this table, so 192 is available under this class C. And if I will write suppose 12.5.6.9. So in this case, now can anyone tell me?
Class C.
Class A, because this first octet has this 12. 12 means it is available in class A 0 to 127. Right, so this is how we can identify the class by first octet. But we have one more rule at the last, means at the last octet. If you will see 0 and 255, it is not used. Why? Because 0 is reserved for the network address. If you want to specify the network ID, if you want to specify a whole network, then you can write like this 192.168.10.0. So that means this is the whole network and you can't assign this IP on your computer system. It can assign on router. It can be assigned on router because in router we have to need to assign the network, right? So here you can assign this IP 192.168.10.0, but in your computer system you can't use this IP 0 for network header and 255 is also reserved for the broadcast. You can't use this IP also, broadcast, right? 255. It's also reserved. So where we it use when suppose as we discussed when you turn on your switch first time, so that time the switch will send the hello packet to all the connected computer system. So it will broadcast the packet, right? It will broadcast the packet. So which IP it will use? So that IP it will use. Any network which you are using, like 192.168.10.0 you are using, so it will send the packet using this 192.168.10.255. So that time only this IP will use. You can't assign this IP on your computer system. If you will try to assign, it will show you error. Like let me show you. I will share this screen. So here you can see. If I will type this IP address 192.168 and 10 dot 10.0. Now if I will do OK, so it will show you the combination of IP address and subnet mask is invalid. We can't assign this. If you put 255 in last and then OK, so it will show you again this error. So that means we can't assign this 0 and 255 in last. Right? So this is also the case. Now is that clear? Next thing is after that, after just reserve some IP address and just created this type of classes. I now create one more concept, that is subnet mask. Subnet mask. So subnet mask means what? Why the subnet mask used? So subnet mask is used to define network and host path in your IP address. Yes, we have the IP address, we have the classes, we have the whole IP address. We know the IP address. When the IP address has 4 octet, that's okay. But how will identify the network part and the host part, where we can assign the host and where we can add the network, when this network will be changed, and how we can uh, just assume like that, how we can just change the host. So this is assigned by the subnet mask. So here if we will see, so suppose this is my IP address 192.160.10.6. Right. So how we can identify where we have to need to change if we want to add an system and an PC, then where we can change. So this can be identified by this subnet mask. So subnet mask, how we can use? So why INA? For class A, this subnet mask is assigned 255.0.0.0. For class B, 255.255.0.0. For class C, that is 255.255.255 and 0. That by default it is assigned by the INA. Now how we can identify which is the network part and which is the host part? So for that we can see like that. Suppose I'm just taking this first one, first subnet mask of class A. If I will write this 255.0.0 and dot 0. Now if I will uh, convert this subnet mask into binary form, then what will be the binary of this 255? 1118 times 4, 5, 6, 7, 8. Now 0 for 0, 008 times 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 3, 2, 6, 6, 7. And now for last 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, now this is the binary of the subnet. So now we have one more rule in binary for the network. 0 is denote host bit, 0 is for the host, and 1 is for the network. Right, so here you can see where this 1 available in first part. So that means in class A, the first octet, the first part is for the network, and 0 where is available in second, third, and fourth part. So that means the second part, third part, and fourth part is for host. First is for network, and then this second, third, and fourth part is for host. So this is how we can identify the network part and host part. That means if you will write any IP of class A 10.0.5.9. So how we can identify the network part? So for class A, we have the subnet mask, this 255.0.0.0. And as we discussed, the first part is for the network, because in first part we have 255. We have one available. So this is the network part. And except all the part, rest all the part is for the host. So if you want to change the host, if you want to add any PC, and if you want to change the IP address of your machine, and you don't want to change the network, then you can only change the second, third, or fourth group. You can just write here like you can change this 0 into 9 or any IP, 5 into 8, 9 into 19. You can change any IP. But if you will made any change, if you will make any change in this first block, if you will change this 10 into 11, then network will change. So this is a different network. For class B, same thing. So in class B, we have 255, 255 available in first and second part. First and second part. That means in first part and second part, this two parts is for the network, and the last two parts is for the host. So if I will write one IP of class B, suppose 172.16.5.9, so this is the class B IP address. If you will see in this IP address, So you can see here, because for class B, we have this subnet mask. So the starting two octet is for the network. So this 172 and 16. This is for the network part. And the last 5.9 is for the host part. So if you want to add any PC, then you can only change the last two parts. You can change this 5 and then 9 also. But if you will make any changes in this starting two parts like 172 or 16, then your network will change, right? Then if you want to compare with that IP or with that PC, then in that case you have to use one router also in your network, and you have to do routing in on that router. Right, so this is the mean of subnet mask. In class C case, same thing. We have the first, second, and third part is for the network, and last part is for the host. So this is my class C IP 192.168.100.6. So if you will compare with these two IPs, first is 192.168.10.6 and last is 100.6. So as we discussed, the first, second, and third part is for the network. So you can see here this 10 change into this 100. So that means the network change. If you want to change the host, or if you want to add any host, if you want to assign IP in same network, then you can only change the last part, last octet. Otherwise, if you will make any changes in first, second, or third, then your network will change. That's it. This is a mean of subnet mask. Now just let me know, is the this subnet mask is clear or any doubt? Okay, this is IP address classes as we discussed. Subnet mask also discussed. Now how we can identify that, how many network will be created in class A, class B, or class C, or any class, and how many PC we can add in a single network of class A or class B or class C. So for that, we can use this subnet mask also. How we can just count this type of thing? So we can calculate using this method. Just see here. So I'm just calculating this class A IP address. Here. Hmm. Now just if you will see here, so this is the range of class A 0 to 127. And if you will convert this range into binary form, so for 0 there is 80, and for 127 there is 0 and 1187 type. Right? So this is the IP address of, and this is a binary of this IP 127. If anyone don't know how to convert, so in short way I'm just telling you. For that we have the formula. We can write like 1 and then double it. Just 2, then 4, 8, then 16, then 32, then 64, then 120. Right? We have to write these. Why we write only till this 128? So because if you will add this numbers like 128 plus 64, 192, 192 plus 32, 224, plus 16, 240, plus 8, 248, plus 4, 252, plus 2, 254, and plus 1, 255. And in IP address, we have the last digit is 255 only, right? And if you will count it, so this is 1 field, 2, 3, 4, 5, 6, 7, 8. And in IP address, we have only 8 bits. So for that, I'm just writing this 8 bit only. And then if you want to convert any IP address like 127, so if you want to convert that IP, so just start to calculate from left to right, right? From here, left to right, and just see which number you have to add to just for this 127. So if I will see this 128, so it is larger than 127, so 0. 64, okay, we have to take this. So 1, 32, 96, okay, and 16, 112, okay, and then 8, 127, okay, that's okay, and then 4, so 124, okay, 126, okay, and 127. So this will be the binary of this 127. So 0, 1, 1, 7 times. So this is how we can convert any decimal number into binary. Right now, if you will see it, so in this binary, if you will see this 0 0 0 0 8 time and this 0 1 1. So here you can see this 0 is never changed on any IP. Right? This 0, the first one. For 0, it's a 0. And for the last one, 127, it's also 0. If you will convert any IP like 1, 2, 3, 4, or 126, any IP. So always this 0 is set on 0. It is not changed. So that means this is a unchangeable bit. Unchangeable. Unchangeable. At this 0, this first one. So now if you will see here, so class A IP address range from, you can assign this IP address range on your system. So you can assign 1 dot xxx. Xx means what? This is the network. So you can't change it. If you will take this one network, 1 dot, so this is the host part. So you can change this. So that's why here this X is written to 127, 126, the last network. So here, this is the also for the host part, except. And in second point, if you will see the IP range, 127 is for the loopback, as we discussed. Okay. Now the subnet mask of this class A is 255000. So if you will see in this subnet mask, we have this network part. Means here we have bit network. If we will write this network bit and then host bit, right? So network bit we have 8 and host bit we have 24. So here if you will see number of network, if we calculate the number of network, so to keep 2 power, we have to just count this 2 power and then the number of network bit, right? Number of network bit is 8. Then why I just write this 7? Because never this unchangeable bit will take the part of a network bit. So that's why I just minus this unchangeable bit. So we have this unchangeable bit 0, only 1. So I just minus this one, 8 minus 1. So that's why I just took this 2 power 7. If we will calculate this will be 128 minus 2. Why this minus 2? As we discussed, always for any network 0 and 255. That 2 digit will not take the part of any network. Why? Because 0 is reserved for the network ID, 255 is for the broadcast ID. So I just minus 2. No, 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 no. Actually, this is not for the that part. That is a mistake. Yes. Let me put this. Now see, why this 2? Actually, this 2 is for the class A. Because in class A, we have this 0 and 127 actually. Right? In class A, we have 2 digit reserve. Actually, we are talking about this network. And I'm just telling about this host part actually, this 2. So this 2 is for the 0 and 127 and it is applicable only for the class A. So in class A we have 0 and 127. So that's why I just minus this minus 2. So we have total number of network 126. Means if you are using class A or if we talk about the class A, so in class A we can create 126 net only. If we talk about the host, so in host part we have number of hosts 2 power 24. In host part we don't have to need to minus any unchangeable bit or anything, right? Because we are talking about this part 0 to 127 or this is the first octet. Because as we discussed the rule, always the first octet denotes the class of IP. So this is the first octet. So now this is only applicable for the network, but host part just write the all the bits. So how many bits available in this? So here we have this 24. I write just 2 power 24 minus 2. This 2 is for the 0 and 255. 0 and 255. 0 is for the network ID and 255 is for the broadcast ID. So now if we will calculate 2 power 24, so it will be the 1 crore 67 lakh 77,216 and minus 2, so it's 1 crore 67 lakh 77,214. Now, so this is the value. we can just connect this much host with a single network of class A, right? 1 crore 67. Now, class B. So, by same way, if you will see here 128 to 199, this is the range of class B. If you will convert this, so 128 available in first place, so this 1 and then all the 0. So 1007 times and 191. 191 means 1, 0 and 1 1. That if anyone has any doubt how this 1001 is come, so just let me know. Otherwise, this is the range of this uh, class B. And if you will see here, so for first IP or for first network, this is 10. It is not changed. And for last network, it's also 10. And except rest, all the bits are changed. 0, 0, 0, 0. All the bits are changed. Only this 10 is unchangeable. So that means here we have two unchangeable bits. Two unchangeable. We have two unchangeable bits in class B. So if you will see here, class B IP address range started from 128.0. This is the first network. And then this is the host part. So you can put any IP to 191 and 255. This is the last network, right? And the default subnet mask of class B is 255.255.0.0. And now if I will see the network and host bit, so network bit we have 16, host bit we also have 16. Now if you will see network part, so the same thing. In network bit, you have to minus the unchangeable bit. So now it's 40 because in class B we have two unchangeable bits. So 2 power 40. If you will count this, so it's a 16,384. Now the number of hosts. So in host part we have 16 bits, and as we discussed in host part, you don't have to minus any number like unchangeable. So this is 2 power 16. If you will count this, so it will be 65,536 minus 2. So this 2 is again for 0 and 255. And because we are talking about the host part. So in host part, the last octet never be 0 or 255. So 0 and 255 minus. So it's a 65,534. That means in class B, you can create 16,384 network, and in every network you can add this much PC, 65,534. This is the class B. Okay, so now next is class C. So in class C, same thing. The range is 192 223. If you will convert this decimal digit into binary, so that will be 11011 and 006 times. And for 223, it's a 11 and 0 and 115 times. Now, if you will see this, so for first network or first IP, this is 110, and in last also this is 110, and rest all the digits are changed, all the binary digits are changed. So that means here we have three unchangeable bits. Unchangeable. We have three unchangeable, and here if you will see class C IP address range started from 192.0.0.0. This is the first network, and the last network will be 223, 255, 255, and last is the host path. This is the last network. Now, if we talk about the default subnet mask, so there is 255, 255, 255. If you will count the network bit and host bit, so in network bit we have 24, and in host we have 8. Now, if you will calculate, so for number of network, the same rule, you have to minus the 3 for the unchangeable bit. So we have 21 bit left for the network. So this 2 power 21. Then the value will be 20 lakh 97,001. 52, right? And for number of hosts, that is 2 power 8, the host bit, and minus 2. Minus 2 means for 0 and 255. So if you will count 2 power 8, that is 256, minus 2, that is 250. So if you are using class C address, so in class C, we can create 20 lakh 97,152 network, and in every network we can connect this much host, 254 hosts. Right? So now let me know for class C. Is that clear? Okay. So after that, class D, the same thing. We are not using class D in computer network, but if we want to count something, so the same thing we can do 224, 239. And if you will convert this into binary, so that will be the binary. Here, if you will count, so in first network, we have this 3 time and 0. And in last, we have also this 1 1. Means we have 4 unchangeable, unchangeable. Right. So class D IP address ranges started from 224,000 and 239,255,255. Because in class D we don't have any type of subnet mask available. So that's why we can't count any network and host part. In class A, B, and C we have the subnet mask, so that's why we are able to count the network and host part. But in class D we don't have any subnet mask. So you can see class D is reserved for the multicasting. In multicasting, data is not destined to the particular host. That's why there is no need to extract host address from the IP address. So class D does not have any subnet. In class E, same thing. Class E is reserved for the experimental purpose, only for research and development. So in this class range, we also don't have any subnet mask. So that's why we can't calculate any network part or host part here. Right. So this is the classes of IP address and on the subnet mask. So as we discussed about the subnet mask, classes of IP address and IP version 4. After that, if you want to understand the IP version 4 addressing mode, so in IP version 4, we have 3 types of addressing mode. Means we can send the data by 3 mode. Number one is unicast. That means you can send data from one PC to another PC. Means one to one communication. Easily we can say unicast means one to one. Broadcast means one to all, and multicast means one to many. If you are sending your data from one PC to many PC, that is multicast. If you are sending your data from one PC to all PC available in your network, that is broadcast. Right. So now we have some reserve address. The next thing is IP version 4 reserve address. INA reserves some address for different purpose in IP version 4 address. So if you will see for the reserve address, so first reserve address is private IP address. Right? Private IP address means what? For every class of IP like ABC, which we are using in computer network, has some address reserved as private IP address, which you can use within your network, like your LAN network, your campus, your company, which is your private network. And simply we can say for the LAN purpose. If you are creating your LAN network, then in LAN network, which IP you have to use. So that is the private IP address. So that range reserved by this INA. So this address cannot be routed on the internet. If you will try to route this type of IP address on the internet, you can't route this type of IP address. So the range is, if you will see here, in class A, B, and C. In class A, we have this range 10.0.0.0 to 10.255.255.255. That means the whole network of 10. And this is the whole network of 10. So as we discussed in class A, so in class A range, we can connect 1 crore 67 lakh 77,000 and 214 PC. So that means in this network, you can connect this much PC. And the subnet mask is same as we discussed in class A. Right? So this IP is reserved for the LAN. If you want to create your LAN network, so that if you want to use class A IP, so you can only use this range of IP address. Yeah. In class B, we have this range 172.16.00 to 172.31.255 and 255, and this is the subnet mask. So, so now can anyone tell me how many network is there? It's very easy actually. If you will see here, yes, see. In class B, we have two parts for the network 172 and 16, right? And this is also the class B. So this is the network part. And if you will see network part, so this 16 change into 31. That means what you have to do, you have to just count this 16, 17, 18, 19, and the last 31. So what will be the answer? There is 16 network only. If you want to create any LAN and you want to use class B IP, so you can use 16 network there. You can use any network IP there. Clear?
Okay, sir.
Yeah. Now in class C, if you will see 192.168.0.0 to 192.168.255.255. Now just tell me how many network is there in this range?
256.
256. Right, so 256 why? Because you have to also count this zero also, right? If you will count from zero, zero, 1, 2, 3, and the last is 255, then it will be 256. Oh, so there is 256 network available. If you will see in any LAN network in your organization, also in your home, if you have the broadband, so there also, and in this virtual machine also, in my machine also, if you will see, always you will get this IP 192.168 is same, and the next field can be the change. Like in my virtual machine, that is 78, as we discussed, right? And in some PC, I think that is 87 also in some machines, and in my system that is I think 0 or 1, 192 160 at 0, or I think 1. In your network it can be changed, but this range always will be started from 0 to 255 only. So that is why we will get by the ISP this range for the LAN purpose, this class C. We can also make change on a router and change this IP into this and this IP, this class B or class A IP. But if you will change this IP, suppose if I want to change this 192 into 193, if I will change this IP on my router, then you can send the data from one system to another system in your local network, but you can't access internet, right? Because on that IP, which is not available in this range, you can't access the internet. If you will try to access the internet, it will be show you something like error, network connection is not available. This type of error it will show you. So that's why this range is reserved for the private IP. So always in any LAN you will get this type of IP. So you have to remember this range, because if you will work like network administrator or network engineer, that time you have to just think about that which IP you have to assign for the LAN, which IP you have to assign for the network, and which network you have to use, how many PC you can connect there for a single network, and for class A, class B, or class C network. Everything you have to understand for that purpose, right? So this is the private IP address. So is that clear? So now next reserve address is, so we already discussed about this loopback address. Loopback means the IP address range started from 127.0.0.0. The whole network of 127 means 255.255.255. This is reserved for the loop. So loopback means it's a host self address. We can also say it's a local address, local host address. This address is mostly used for testing purpose. If you want to test your NIC, then you can use this type of IP. And how you can use, if your host machine can successfully ping with this range 127.0.0.1 or any IP started from 127. So That means your TCP/IP software stack successfully worked or successfully loaded and working on your machine. So TCP/IP software stack means what? In our machine, we have the NIC, we have the port RJ45 or any port, or in Wi-Fi case, we have the Wi-Fi NIC, Wi-Fi adapter. So in computer, we have the rule for every hardware, we have to need a software for every hardware. And in any operating system, for the hardware purpose, we have the drivers, and we have the drivers. And what we have done, we just install the driver and then we can configure that hardware. So the same thing is here. If you just uh, attach your NIC in your system, after that you have to need one driver if you want to use this NIC in your operating system, right? So when you apply any IP address when you apply any IP address on your NIC, that means you just apply this configuration on this driver, which is installed for this NIC, right? So when you ping this 127.0.0.1, so this IP will check for that driver. If driver will available, so in driver we have this IP available, means this will create the loop, right? It will send the hello packet, and also it will receive the same packet. Then it will give the reply to the machine and get the reply with same machine. So that is loop back. After that, link local address. So now this is very important in troubleshooting purpose also if you are working in network. So okay, so now can anyone tell me link local address? Then I will tell you what's the mean of this. What's the mean of this link local? Or if you heard anything about this link local, or if you seen on any system, let me know. Any idea? No idea. Okay. So did you ever saw this type of IP 169.254? Anyone? Chanak, Praveen? Any idea?
No, sir.
No idea. Okay. Now, so the first rule is, suppose we have this system, and in this system we have one NIC. Okay. We have NIC. And if you connect this NIC with the medium means if this NIC is for the wire, so if you connect a wire with this NIC, then this is mandatory to assign one IP address on this NIC. Right? This is mandatory. You can't skip this. You have to assign one IP address on this NIC if it is connected with any type of network. So we have two methods to assign the IP address as we discussed earlier also. First is obtain IP address automatically. So how we can obtain the IP address automatically? So for that, in network we have one protocol, that is DHCP. DHCP means Dynamic Host Configuration Protocol. So using that protocol, we can configure the DHCP server. By default, this DHCP also works on router also. If you enable that DHCP service on router, then automatically router will provide you IP. And mostly cases it works. Like if you take the broadband from the ISP, so ISP by default enable the DHCP on that device. So when you connect your device like mobile or your system with the Wi-Fi or with the cable, then automatically your device get the IP. So how they get? Because they enable that DHCP service on that router. The second case is in organization, we have one more option available. We can create the server, and on server we can create DHCP server, and we can assign the range according to our need, which range I want to assign on the device of my network. So we can create it. But and the second method is you can assign the IP address manually, as we assigned also. So we have only two methods. But the condition is suppose we have not any DHCP server available in network. Suppose I just turn off the router, right? And I have not any DHCP server available. And I also didn't configure manual IP address on this machine. And this machine is connected with the network. So how this machine will configure IP address? How this machine will get the IP address? And this is the rule. IP address should be there. So for that, in every operating system, it can be Windows, it can be Linux, or it can be Mac OS. In every operating system, there is one protocol that is APIPA. APIPA means Automatic Private Internet Protocol Address. What's the use of this protocol? So this protocol automatically assign one temporary IP to your NIC when your NIC didn't get any IP from any source like manually or DHCP server. That time this protocol, your operating system automatically assign one IP address on your NIC for temporary purpose. When DHCP server will be available, then it will get the IP from the DHCP server. Only you have to refresh your NIC, right? So this APIPA means what? So this APIPA will provide a range. So that range is 169.254.0.0 to 169.254.255 and 255. So this range is known as link local address, which is assigned by the APIPA protocol by your operating system. Right? So this is the mean of link local address. So here you can see, in case a host is not able to acquire an IP address from the DHCP server and it has not been assigned any IP address manually, so the host can assign itself an IP address from a range of reserved link local address. So this is the range. So suppose if you are working as a network administrator and in your network some PC has or all the PC has this type of range. You will see this type of range. Then what how you can troubleshoot? So the first thing is firstly you have to check your DHCP server. So the chance is in your network there is not any DHCP server is available. The chance can be your router can be turned off or router it can be disabled also. So you have to check that thing. This is the main. Right. So now let me know the link local address. Is that clear? Okay, this is link local address. And the last reserve IP address is public IP. So public means what? These IP addresses are reserved for the public purpose like internet. On internet, which we discussed earlier, loopback, link local, private IP address. Rest of all the IP address available on the internet from class A to class C. All the IP address. When you just purchase an internet connection, so that time you will get the internet get an IP address. So that IP address means suppose you just recharge your mobile or recharge your SIM with any plan like 399 or any plan. So when you just pay for that recharge, so that time the ISP assign one IP to you for that time of period like 28 days or 56 days or any days which they provide. So this is a mean of the public IP address. If you want to check your public IP address, so we have one more method. Let me show you. So share. If you want to check your public IP address on any machine, you can also check on your mobile also. So you have to type here what is my public IP, and here just click on this link www what is my IP. The second one,
Can we get from what is my
what is my IP address.com. So this works. Now here you can see. So this is my IP version 4 address 223, 233, 6490. Right, this is my IP address, and my ISP is Airtel. So this is how you can check your public IP. This is my public IP. And when I will change my recharge after end this recharge, when I will again recharge my broadband, that time I will get another IP. So you can also see in your case, suppose you have, if you will check on your mobile, so you will see one IP. Okay, and then screenshot that, take the screenshot of that IP, and when you will just recharge again on your mobile, then just check. So this IP will be changed that time, because when you pay for the internet, that means you just pay for the single IP.